This is the review for Test 1, which is on Chapter 2 Sets and Chapter 3 Logic. Question 1, express the set using the roster method, the set of natural numbers less than or equal to 9. So the roster method just means we need those squiggly brackets and commas separating all the elements. The natural numbers were those positive whole numbers that start at 1. So we'll just simply list in a set, those curvy brackets, all the positive whole numbers from 1 all the way through 9. It does say or equal to 9, so we do want to include the 9. So squiggly bracket, 1, comma, 2, comma, 3. Now if you want to list them all out, you can. When it is a larger set, after you list 3 numbers, I'm going to write dot, 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 that ellipse, meaning continue the pattern, comma, all the way to 9. I do need to write the 9 because I want to say, hey, we are stopping at the number 9. And that's the final answer. Question 2 is another roster method question. It says express the set using the roster method. And we see as we look at this set, this is currently in set builder notation. I know that because of that one vertical bar there, that's the such that bar. If I were to read this current set out loud, it would be the set of x such that x is an element of the natural numbers and x is less than 4. So it's very similar to question 1. We do want to be careful though with what direction this inequality arrow is pointing on the test, and if there is an equals bar or not below it. If there's an equals bar, we'll include the number beside it. This particular question, though, does not have an equals bar, so that means I'm not going to include the number 4 that is beside it. So yet again, roster method, we need the squiggly set brackets. I want all the natural numbers, those are the positive whole numbers, that are less than 4. Remember, the arrow, the inequality arrow, points to the direction on the number line of the numbers you want to keep. So I want to keep all the natural numbers to the left of 4. So that's 1, comma 2, comma 3, and I end at 3 since there's no equals bar below it, so I'm not going to actually include 4 itself. Question number 3, find the cardinal number for the given set. So set B equals the set of 2, 7, 12, and 17. Cardinal number means you just simply count up the number of elements that are in the set. So how many elements are in the set? And this is an easier set because they used roster method with commas. So I just simply count up the number of items around the commas. So we have 1, 2, 3, 4 numbers in this set. 2, 7, 12, and 17 are the numbers themselves, but there are 4 numbers. So I have little n for number of elements in B equals 4. You don't have to use the fancy notation like I did. I'm just simply looking for the number 4 for the final answer of this one. Question 4 says write subset or not a subset in the blank so that the resulting statement is true. The set on the left has 2, 3, 1 in it. The set on the right is 1, 2, dot, dot, dot. So continue that pattern all the way to 7. So pretty much the set on the right are all the natural numbers from 1 to 7. A subset simply means that all of the items in the set on the left are also listed again in the set on the right. So let's see if that's true. The number 2, yep, that's located in the set on the right. The number 3 would be part of the dot, dot, dot. It's in the middle of 2 and 7, obviously, so that's there, check. The number 1, yep, that's there too. So yes, the set 2, 3, 1 is a subset of the set of numbers from 1 through 7. Subset kind of looks like a squish C with an equals underline below it. Question 5, write subset, proper subset. So if there's no equals bar below the squish C, remember that's proper subset. Both or neither in the blank so that the resulting statement is true. Now, technically, if you say something is a proper subset, it would have to be both, proper subset and a normal subset. So technically, if you select proper subset, that's the same as answering both. So there are actually 3 different answers to choose from. It's either a subset only, it's both proper subset and a regular subset, or it's neither of them. Looking here, we got the set of letters RVT on the left, on the right RVMT. So I'm seeing at the very least that it is a normal subset simply because all the letters on the left side are also in the set on the right, because R is on the right, V is on the right, and T is on the right. It's also a proper subset because the sets are not the same set. They're not equal. So they're not an exact match. I'll just put not the same. So if it's a subset where the sets are not the same exact set, they don't have the same exact elements. In other words, one of the sets has at least an extra element, and it does. The set on the right has the letter M in it, which the set on the left does not. Then it's also a proper subset. So I'm going to write both. The final answer is this is both, RVT is both a subset and a proper subset of RVMT. Question 6, write subset, proper subset, both or neither, again in the blank so that the resulting statement is true. The set on the left is 2, 4, 6, 8, 10. The set on the right is 8, 6, 10, 2, and 4. So first let's check to see if it's a regular subset. So 2, yep, that's in the set on the right. 4, yep, that's also in the set on the right. 6 is also on the set on the right. So is 8, and so is 10. So at the very least, it's a regular subset because all the elements in the set on the left are also in the set on the right. Now, we're going to check to see if it's also a proper subset. Please keep in mind that to be a proper subset, it has to pass 2 criteria. It has to be a normal subset, which we just said yes it is. And the sets should not be the same exact set. In other words, they should be different sets. At the very least, one of the sets should have an extra element from the other. If I look closely, it fails criteria 2 because both sets have the same exact numbers in them, no more, no less. Both sets have a 2, a 4, a 6, an 8, and a 10. So it's not a proper subset because the sets are the same exact set, so it's only a normal subset. So just subset only would be the final answer. I know that's a horrible looking subset I just drew. Should be a longer squished C, but you get the idea. Question 7. How many distinct subsets can you create from the following set? The set with the little a and the little b in it. So the formula to count up subsets is 2 raised to the little n power, where little n represents the number of elements. You might want to write that formula down on your formula sheet so that it's ready to go come test time, and you know similar question will be question 7 as well on the actual test. So if I count up how many elements I see 1, 2 elements. So n, the number of elements is 2, a and b. So 2 elements. So take that 2 and plug it into the formula. It's the exponent of the formula. It's always base 2 in the formula. So base 2 holding up an exponent of 2. So 2 raised to the second power would be 4. There are 4 different subsets you could create from that original set. Now you do not have to list the subsets. I only ask on the test how many subsets you can create. Question number 8. Use the Venn diagram to represent set B in roster form. So everything that's in circle B, let's go ahead and list that. Oh, And actually, I have a B below the question. I didn't even see that there. So it's down here. So it is a set, so I do need curvy set brackets technically around my answer. And I can list these numbers in any order, but inside circle B, I have an 8. I have a 10, comma in between all the numbers because it does want roster form, 14, 17, and a 19. Close the brackets, and just be careful because on the test I might ask for set A or the universal set instead, so you want to make sure you're familiar with how to read a Venn diagram. Question 9 says to use the Venn diagram to represent the set A union B in roster form. Keep in mind, union means you combine those two sets together. Doesn't matter if they repeat or match or not, just whatever an element in either set is part of the final answer. So in the case of Venn diagram, when you combine circles A and B, that means simply everything inside the circles in any order. It is a set, so I do unfortunately need those curvy set brackets. So inside circles A and B, we have a 2, 4, 9, 12, 15, 16, and 20. So union means to combine everything inside the circles together. And that's it. Now, just please be careful. Knowing myself, there's a very good chance that come test time, instead of union, I might say, hey, what's the intersection? So if this U is opening downward, then I want the intersection instead. If I do ask you for the intersection instead of the union, that would be what the circles have in common, the overlap, which would just be 9 and 12 that I'm circling in black pen there. So just be careful when you get to this part of the test. Is it a union symbol or is it an intersection symbol? Because that makes a crucial difference. Question 10, use the Venn diagram to find a complement. There's a little apostrophe there. So a complement means what's not in the set, but still in the universal box. So what's not in set A, but still in the universal box, or the universal set. So I want what's outside of circle A. So let's get rid of circle A. So a complement, what's not in circle A would be 15, 16, notice I'm just putting commas because this is all roster form, 20, 23, and 26. So you can assume, if I don't specify otherwise, I still want roster form with the curvy set brackets. And again, just be careful because on the test, maybe instead of a complement, I'll ask you to find B complement. So that would mean what's outside of circle B in that case. So just make sure you're reading these questions super carefully come test time. Question 11 says, let the universal set be little m, n, n, o, p, q, r, and let set B be little m, o, p, r. Use the roster method to write B complement. Remember, B complement means what's not in set B, but still in the universal set, or the opposite of that set, of set B. So let's get rid of the matches between the two sets because we want what's not in B. So let's get rid of little m, little o, little p, and little r, and all the leftover stuff in the universal set is going to be B complement or B apostrophe. So we're left with a little L, comma, N, comma, and Q. So little L, little N, and little Q in set brackets, roster method there, commas between it. That would be my final answer for B complement. Question 12. Let set A be little bvy. Let set B be little dvy. find A intersected with B. So remember, intersection means matches, or what do the sets have in common? You can use either memory trick. So A intersected with B equals, let's write our answer in roster form with the curvy set brackets. So as I look at both of these sets in the original question, they both have a little v and a little y in common. So those elements are going in set brackets with a comma in between it, and that's my final answer. Again, make sure you read the question carefully. Maybe I'll have a union symbol on the test instead of an intersection symbol. If I do have a union symbol, you would just combine the sets together. Question 13 is going to be a two-step question. We have let the universal set be 9, 15, 8, 14, 16, 13, 21, and 19. Let subset A of that set be 9, 21, and 19, and subset C of the universal set be 15, 8, 14, 16, 13. Find A complement union C or united with C. So I have two set operations. We would normally do what's inside parentheses first, however, there are no parentheses. So then we would do complement from left to right next. So step one is I got to figure out A complement to begin. A complement is what's not in A, but still in the universal set. So if I compare set A with the universal set, I don't want 9, because remember, I want what's not in set A. I don't want 21, and I don't want 19. So what elements are left in the universal set would be 15, 8, 14, 16, and 13. I apologize about that. I am in my office recording this video right now, and my phone was ringing. Of course, it was a telemarketer. Okay, so I just finished up with 13. I still have to write that. There we go. So 15, 8, 14, 16, and 13 are what's not in A, but still in the universal set. That's what A complement means. Now, step 2, we do any union or intersection symbols last from left to right. So it wants us to take A complement and unite it with C. So A complement, we know from step 1, bring that down. I'm just simply rewriting it. You don't have to show out all this work on the test. I'm just trying to explain what I'm doing. Union. And it's just a normal set C, not C complement. So set C, bring that down from the original question, was 15, 8, 14, 16, and 13. Of course, I'm running out of room. And union means to combine the sets, who cares if they match. So when I combine the sets, I'm going to have to move my answer up here since I'm running out of room. But both sets happen to have the same elements. But remember, if that happens on the test, it doesn't matter if they match. Just combine the two sets together if it's a union symbol. So I see a 15, an 8, a 14, a 16, and a 13. Again, both sets happen to match, but we don't care if they match or not with union. So we get back set C or A complement again. And if you want to, you can put the elements in order. I did on the answer key that's posted in Canvas, but you don't have to. You can leave it as just 15, 8, 14, 16, 13. You can write A complement, or you could write set C. Any of those answers would be great for full credit. So you get set C back again for the final answer. Question 14 says to let the universal set be the numbers 1 through 9. Let set A be 3, 4, 7, 9. Let set C be 1, 3, 4, 7, 9. Find the set parentheses A intersects C, close parentheses, complement. There is an apostrophe floating outside the parentheses. This is another two-step question because there are two set operations. So each set operation means another step in the question. So thinking of the order of operations, we do inside parentheses first. So step 1 is going to be A intersected with set C since it's in parentheses. The complement, the apostrophe, is outside the parentheses, so I'm not going to worry about that operation yet. So intersection means matches, or where do the sets overlap? What do they have in common? So if I look at A and C, they both have a 3, 4, 7, and 9 in common. So now, step 2, the other set operation, since I'm done with everything in parentheses, I'm going to do the complement. When the complement is floating outside parentheses like that, it means I'm going to apply it to my intersection, my answer from step 1. So if I color code this in red, if I take this complement here, actually let me just rewrite it as a separate line so it doesn't look too confusing. So I'm going to bring down A intersection C, which was 3, 4, 7, 9. And now I'm going to do the complement. The complement means what's the opposite of that set, or what's not in that set, but still in the universal set. I'll just put but still in universal. So if I get rid of these elements with the universal set, we have a 3, 4, 7, and 9. What's left in the universal set is my answer. So I have a 1 and a 2, a 5 and a 6, and an 8. No set operations are left, so this must be the final answer with the curvy set brackets around it and commas because it's still in roster form. But I do have 1, 2, 5, 6, 8 as the elements for the final answer. It's up to you how much work you want to show. If you want to do more of it in your head, that's fine too. Question 15. A math tutor working with a small group of students asked each student when he or she had studied for class the previous weekend. Their responses are shown in the Venn diagram. Use the Venn diagram to list the set of students who studied Sunday and not Saturday in roster form. So it says not Saturday, so let's get rid of Saturday students. So everything in the Saturday circle is gone, but it does want those who studied Sunday. So which students are in the Sunday circle but not anywhere in the Saturday circle? So that would be right here. And it is still a set, so I do need the set brackets. But Zach, Mary, and Kelly would be my final answer. Just be careful on the test. Knowing myself, I might switch it up. I might say Saturday and not Sunday. So then in that case, you would look at who is in the Saturday circle but not anywhere in the Sunday circle. So just make sure you read the question carefully come test time. Question 16 says a poll asked respondents if they agreed with the statement that colleges should reserve a certain number of scholarships exclusively for minorities and women. Hypothetical results of the poll are tabulated in the Venn diagram. How many respondents disagreed with the statement? So we want to pay close attention to the question at the end. What exactly are they looking for? Here they want everybody that disagreed. And we'll add up all the numbers that qualify together for the final answer. Now if I look at my Venn diagram, I have a men circle, an African American circle, and an agree circle. I do not have a disagreed circle. However, obviously disagree is the opposite of agree. So I must want the complement of the agree circle. In other words, if I get rid of, I don't want who agreed. So if I look at all the numbers outside of the agree circle, that must be disagreed. So 7, 2, 3, and even the 5 are all outside of the agree circle. And you have to do one or the other, obviously. If you're not agreeing, you must be disagreeing. So let's add up those numbers that are in the disagree areas. So that's 7 plus 2 plus 3 plus 5. And when you add up those numbers together, you do get 17 as the final answer. Next question, number 17. Again, a poll asked respondents if they agreed with the statement that colleges should reserve a certain number of scholarships exclusively for minorities and women. Hypothetical results of the poll are tabulated in the Venn diagram. How many women agreed with the statement? It happens to be the same numbers, the same Venn diagram, but they've snuck in 2 criteria. We want to know the number of women that agreed. So my first step is to figure out which numbers are women. I don't have a women's circle, but I do have a men's circle. So I'm going to get rid of the men numbers. In other words, all the numbers outside of the men's circle must be the women. So this 3, 2, 9, and 5, these are all the women's responses in this survey. Now that we've identified the women, we want just those women numbers that also agreed. Just the women that agreed. So which of these numbers is in the agree, are also in the agree circle? So in other words, the overlap of women that agreed. Well, out of the women numbers, these are the only numbers that are also in the agree circle, 9 and 2. So I'm going to add the 9 and 2 together for 11 for the final answer. So if you have 2 criteria, you're finding out where those 2 areas intersect, women and agreed. I would first recommend get it down to the first criteria, which is women, and then from those numbers, which numbers that are remaining are also in the agree circle, the second criteria. So 11, final answer for number 17 on the review packet. Question 18, complete the truth table for the given statement by filling in the required columns. Feel free, by the way, you should have all the answers to each truth table arrow on your formula sheet, so feel free to bring that come test time and use that on the test. So the first thing they want us to do is to negate Q, because you see the little squiggle there for negation, meaning take the opposite of the Q column. If the Q column is currently going TF, TF, the opposite would be FT, FT. Now, the last column they want us to do, they want us to combine the negation Q with and P. So let's get rid of Q. We only want to be comparing the not Q with the P, and you should look up the and, this is the conjunction and up arrow on your formula sheet. When you pair up a T with an F with and, it makes F. 2 T's, like line 2, make another true. FF with and makes false. FT makes false. So you should have FTFF. The only T should be in line 2 because you have 2 T's. A few more truth table and truth value type questions. Next question, they want you to do the whole truth table from scratch, but it says create a truth table for the following statement. You worked for Disney or you did not work for Universal Studios. So when we have to do the whole question from scratch, step 1 is you're going to assign letters first. So I'm going to let P represent the first idea, which is you worked for Disney. And feel free to abbreviate it. I'm just going to write Disney. Technically it's you worked for Disney, but I'm just going to write P equals Disney to abbreviate. Q, you ignore the word not because you're going to bring it back in step 2 with that squiggle tilde symbol. So Q is actually going to be you did work for Universal Studios. You did work for Universal Studios, or I'll just write Universal. Now that you've assigned letters to all of the ideas, step 2 is you're going to rewrite the sentence in symbolic form. So you got to go back through the sentence. You worked for Disney was letter P. Or is the arrow pointing down I promise I'm not drawing the letter V. I just have messy handwriting. That's supposed to be the disjunction down arrow. You did not work for Universal Studios is the squiggle or the negation Q. So really, we're going to do a truth table for P or not Q. Let's see if I have enough room to squeeze in this whole truth table with my big old handwriting. There are two different letters. Each letter needs its own columns. There's a P column, a Q column, and then the P or not Q. And let's go ahead and fill in the 4 scenarios. So it could be true, true. It could be true, false. It could be false, true. Or it could be false, false. Just barely enough room with my big old handwriting here to squeeze it in. Now we're ready to fill out the symbolic form, the last column of the truth table. Going left to right. Step 1, I see it's just a normal P, so let's copy and paste the P column on over, which was TTFF. Step 2, you cannot do an arrow until you have stuff on both sides of the arrow, so step 2 has to be negate Q. Change Q to the opposite truth values. Q is currently going TF, so the opposite of that would be FT, FT. And the last step will go under the arrow. The last step is to apply the OR down arrow to what's on either side of it. Feel free to look at your formula sheet. But line 1, TF with OR makes true. 2 T's, line 2 makes true. 2 F's makes a false. FT makes a true. So my final answers are TTFT. If you want to even write it off to the side, TTFT. Those are the final answers for question 19. Question 20, determine the truth value for the statement below when P is true, Q is false, and R is false. So we don't need to do the whole table. Yay! Truth value, we just simply plug in what they gave to us. Notice the end of the sentence, they tell you what to plug in. They tell you that P is true, they tell you that Q is false, and they tell you that R is false. So I'm just going to simply plug those in. Kind of almost feels like an algebra expression or equation that you're plugging into. So we have negation P, when I look at what I'm plugging into, the symbolic form. So I'm going to take the opposite of P. So if P is true, the opposite of a true is a false. Check. Bring down the and up arrow in the parenthesis. R is false, plug it in. Or, bring down the or. Negation Q, opposite of Q. If Q is false, the opposite of a false is a true. Now we go left to right, do inside parentheses first. Feel free to use your formula sheets. F or T makes another T. And bring down the rest. Bring down the F and the and that are in front. Now we look up what's F and T. F and T, and is very strict. If you have just one F, the whole thing is F. So my final answer is false. The truth value would be false. Question 21, we're back to a truth table. It says complete the truth table for the given statement by filling in the required columns. The first column is to negate P, so change P to the opposite truth values. P currently says TTFF. The opposite of that would be FFTT. Now the last column, negate P, and we have the biconditional arrow Q. So I'm going to do negate P first, which we just did, bring it over, so that was FFTT. Q, bring that over next. It's not negation Q, it's a normal Q. So Q is TFTF. And then the biconditional arrow in the middle, if you look at your formula sheet, if the truth values match, it's true. If they mismatch, one of each, it's false. So line 1, I have an F and a T, which is an F with biconditional. 2 F's, line 2 makes it true. 2 T's, a match makes it true. TF makes a false. So my final answers in blue pen there are F, T, T, F. You do not have to show out all that work. I had 3 steps I showed out there. If you wanted to, you could skip steps 1 and 2 and just go right to step 3, the last step there for F, T, T, F. 22. We are back to truth value. It says determine the truth value for the given statement when P is false and Q is false. So again, they tell you what to plug into the letters. P is false and Q is false. So we have negation P, so the opposite of P. So if P is false, the opposite of a false is a true. Bring down the if-then arrow. Q is false. Plug it in. The if-then conditional arrow, when you have T pointing to F, if you look at your formula sheet, that makes an F for false. So the truth value for number 22 is false. 23, write the contrapositive of the following statement. If you do not complete your math homework, you will not understand the material. Contrapositive gives you an equivalent statement to the original if-then sentence, and contrapositive means you're going to switch the order of the sentence and you're going to negate both sides. Feel free to write that memory trick down on your formula sheet. So switch and negate both sides. You're still going to leave if at the beginning of the sentence, but if you look at the end of the sentence, you're going to bring that to the front and you're going to negate it. So instead of you will not understand the material, if you will understand the material. When you negate the not, it becomes you will. So the opposite of you will not understand is you will understand. So if you will understand, or actually I should just make it sound like a normal sentence. You could even just say if you understand. So if you understand the material, then, or you don't have to write the word then because then is pretty much implied. The beginning of the sentence moves to the end and negate that as well. So the opposite of you do not complete your math homework is you do complete your math homework, or you did. You did complete your, I'm running out of room, so I'm just going to write HW for homework here. So that sentence is your final answer. If you understand the material, then you did complete your math homework. Final answer. And I am looking for a full sentence, not just math symbols for contrapositive, by the way. Last page, yay! Question 24, use De Morgan's laws to write a statement. So I don't want just symbolic form, I want the actual sentence there that is equivalent to the following statement. It is not true that Allison and Andrea are both awake. So the current format this is in, it is not true that means you have a negation squiggle in front of parentheses, P, up arrow, and Q. So if you look at De Morgan's laws on your formula sheet, pretty much what it says is that you can distribute the negation and it affects the and arrow and makes it an or. So when you distribute it to P, it becomes negation P. It flips the and upside down to an or, and then you're going to negate the second sentence as well. So, or you could just memorize, negate both ideas, change an and to an or. And the same with or. If you see the word or on the test, or becomes and. And you negate both ideas. So if you want to just memorize or write this down on your formula sheet, you really don't even need any sort of symbols. When you see De Morgan's laws, just think negate both of the ideas. The word or would become and. In our case, we have the word and, so it's going to become or. And you're going to drop the it is not true that, I should also mention. So you might want to also write that down. So get rid of the it is not true that. So let's put this all together. So the negation of Allison being awake is Allison is not awake. And becomes or. The opposite of Andrea being awake is Andrea is not awake. So this sentence is equivalent to the original. It has the same meaning. Allison is not awake or Andrea is not awake. For our purposes in logic, this particular sentence, it does not matter if you have a comma or not. Not the same grammatical rules as in your English courses. That's the final answer, is that complete sentence, not the symbols, but the actual sentence. Question 25, translate each argument into symbolic form, then determine whether the argument is valid or invalid. You may use a truth table or, if applicable, compare the argument's symbolic form to a standard valid or invalid form. You can ignore differences in past, present, and future tense. And I took this right from the My Math Lab homework, this example. If he likes to eat steak, he will not go out to eat. He will go out to eat. Therefore, he does not like to eat steak. So there are 3 steps to this one. So step 1, we're going to assign letters. So let P represent the first idea, which is he likes to eat steak. The second idea, Q, is he will go out to eat. Remember, you ignore the word not, you'll bring it back with the squiggle symbol in symbolic form in step 2. So he will go out to eat. And those are the only 2 ideas. As you read the whole paragraph over, it only mentions about him liking to eat steak, and he's going to go out to eat over and over again. So we got just 2 ideas. Step 2. Now you're going to rewrite each of the 3 sentences in symbolic form. So the first sentence says if. It does not say if and only if. It's just if. So that means the if then conditional arrow. If he likes to eat steak was letter P. We can assume the word then would come after the first part of the phrase. Then is implied. So it's technically then he will not go out to eat. So then negation, squiggle, not go out to eat is Q. So if P, then not Q is the first sentence in symbolic form. The second sentence is he will go out to eat, which would be just letter Q. Before the last sentence, we draw that big old bar, the therefore 3 dots. Therefore, he does not like to eat steak would be squiggle or negation P. Now, hopefully we can avoid a truth table. So step 3, to avoid the long truth table, we're going to look at our formula sheet, the standard forms of argument, and see if we can find either an exact match with our symbolic form in step 2, or at least a match of the concepts of the ideas. So I'm going to go ahead and bring up the standard forms chart onto the screen, and let's then look for a match. So here's that standard forms of arguments. And as I look for a match between step 2, let's see here. I do not see an exact match, but I do see a match of the concepts right here where I'm circling. So this is in the first row, which is the valid arguments row. So this is valid for the final answer. And if you look closely, it has P in front of an if then arrow in the first line. It has the conclusion, the bottom line being not P. The only thing different is that Q and negation Q are switched, but that's okay because it's the same idea. It's still saying, hey, I have an if then arrow in line 1 pointing to some sort of Q, in our case negation Q, and you're going to take the opposite of that Q for line 2. So it actually is a match. It only has the Q and not Q switched around, but it's just simply saying, hey, take the opposite of that Q and make it line 2, and that's what we have here. So it's a valid argument by contrapositive reasoning. So you could just simply say valid for the final answer for number 25, last question.